Algebra 1, Lesson 110. We are learning about the quadratic formula, how to use it, and how we can solve our quadratic equations using this formula. Now, remember that when we have our quadratic equations, we have many different ways to solve them. Things like graphing, or completing the square, or solving by using square roots. Well, today we're going to use this formula. Now, this formula may look quite complicated, lots of different variables, but we are using a, b, and c just like we have in the past. We're using them from the equation y equals our normal quadratic equation. So, let's see if I can get my pen to work today. We have y is equal to ax squared plus bx plus c. And so all of our different variables that we see in this quadratic formula are coming from our normal quadratic equation. Now you may look at this formula and wonder where we get it from. Well, that's a valid question, and it's a combination of taking our normal quadratic equation and using our skills from completing the square. So I'm just going to show a really quick proof of this. So if we take my quadratic formula, ax squared plus bx plus c, and we equal it to 0 since we want to solve it, and that's what we are doing. We're trying to figure out when y equals 0, we are looking for those x-intercepts. Now, in order to complete the square, remember that we have to have x squared without a coefficient, which means I'm going to have to divide everything by a in this case, which means we get x squared plus bx over a, and then I'm going to take this c over a and move it to the other side, which means I'm going to subtract it. So we get equal to negative c over a. Now we can complete the square, but remember how we do this. We need to take this b term, divide it by 2, square it, and add it to both sides, which means I'm going to get x squared plus bx over a plus, I'm going to say I need b over 2a, so that's my half of b over a, and I'm going to square it. I'm going to add that to each side. So negative c over a plus b over 2a squared. All right. And then what we need to do, we're going to expand a little bit and just basically on this left side factor it into that perfect square trinomial. So we end up getting x plus b over 2a, all of that squared, is equal to, well, we can simplify this other side and also combine it, which means in this first case, and I'm just going to write it up here, we have negative c over a, and we want to add to that b squared over 4a squared. I just expanded here to say what do we get when we actually square that term. And we need to get something that I can actually combine. So this is where our rational equations come into play here, and I need to multiply this first fraction by 4a in order to get those common denominators, which means that I end up with b squared, okay, I have this b squared from right here, and then I have 4a times a negative c, so that's minus 4ac all over 4a squared. Now, in order to solve this for x, remember that I need to take the square root of each side. So I'm going to do that. I'm going to have to take the square root of each side, which means that we get a plus or a minus answer here. And so I say x plus b over 2a is equal to plus or minus, and I'm going to kind of split apart this square root to say I have plus or minus the square root of b squared minus 4ac, and then I'm dividing that by the square root of 4a squared. Well, if I take the square root of 4a squared, that actually just gives me 2a. All right, and we're getting really close to this formula now. You can probably start to see where each of these different parts comes from. And the last thing I need to do is subtract this b over 2a. Thankfully, what's pretty awesome here is that we have common denominators already with that 2a, which means when I subtract it from each side, I get x equals negative b, so that minus b that I took from each side, plus or minus the square root of b squared minus 4ac all over 2a. And when I plug in all of my different variables here, if I actually have a quadratic equation, if I plug in my a, my b, my c here, I figure out the possible 0, 1, or 2 different solutions I have for my quadratic equation. So that's just a quick proof of the quadratic formula here. And let's now practice using this. Now, before we go on, there is a little song that you can do here that I learned when I was in school, and it's to the tune of Pop Goes the Weasel. It helps you remember it. It always helps me remember it. So it goes like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So whenever you're doing your quadratic formula, you can maybe, if it helps you, try to think about that song so you can remember all of the different parts, because it's kind of hard to remember all of them. So let's try it now with this x squared minus 9x plus 20 is equal to 0. So in this case, a is 1, b is negative 9, and c is 20. So I'm going to plug this into my quadratic formula, simplify, and find my possible 2 answers. So x equals negative b. Well, if I have a negative 9 plus or minus the square root of b squared, so my negative 9 squared, minus 4 times a, which is 1, times c, which is 20, all over 2 times 1. So x equals, I'm just going to start simplifying a bunch of things here. Negative 9 is a positive 9, plus or minus the square root. Well, I get 81 minus 80 over 2, which equals 9 plus or minus, well, the square root of 81 minus 80 is the square root of 1, which is just 1 over 2. And all I have to do here is split it into the 2 different possibilities. We can say this is 9 plus 1 over 2, or 9 minus 1 over 2. In the top one, I get 10 over 2, which is 5. In the bottom one, I get 8 over 2, which is 4. Meaning my 2 solutions to this, my 2 x-intercepts, are at 5 and 4. Now, when we have found our 2 solutions, check both to make sure they are not extraneous solutions, especially making sure that we don't get a square root of a negative number in underneath the radical, okay? Or in this case, really, we just want to make sure that when we plug it into our equation, it makes sense. That's the easiest way to do this. So if I do this and I say x is 5, we have 5 squared minus 4 times 5 plus 20. So we have 25 minus 20 plus 20. All right. And we say, does that equal, let's see. We want to make sure that equals 0. And let's see. Oh, this is a 9 minus 5. Sorry about that. 9 minus 5, that makes a lot more sense. So minus 45. So 25 minus 45 plus 20 does give me 0, so that is correct. We try it with the 4. We say 4 squared minus 9 times 4 plus 20. Does that equal 0? Well, we get 16 minus 36 plus 20 equals 0. That is a true statement. So both of those solutions do actually work for this quadratic. Let's try another one. And then we'll get into some harder ones that may not have whole number solutions, and that's okay. All right, so in this one we say a is 2, b is 6, c is 4, and we plug it in. So x equals negative b plus or minus the square root of b squared, so 6 squared, minus 4 times 2 times 4, 4ac, all over 2 times 2. So x is equal to negative 6 plus or minus the square root. Well, we get 36 minus, let's see, 8 times 4. So we get our, let's see, oh, sorry, 8 times 4, we get 32. There we go. And we divide it by So we end up with negative 6 plus or minus the square root of 4, which is 2, over 4. And we split it into our two possibilities, negative 6 plus 2 over 4, and negative 6 minus 2 over 4. We end up with negative 1 here. We end up with negative 2 here. Okay? And we plug them back into our equation. So 2 times negative 1 squared plus 6 times negative 1 plus 4, does that equal 0? That is the goal. So we get negative 1 squared is 1 times 2 is 2, minus 6 plus 4. And that does give me 0. So we are good to go. And we try the second one. 2 times negative 2 squared plus 6 times negative 2 plus 4 is equal to 0. Maybe. Let's see. So negative 2 squared is 4 times 2 is 8 minus 12 plus 4. Does that give me 0? Yes, it does. Okay, so both of those are true solutions for this quadratic. Okay, you need to do that with each one. I'm going to stop showing it all together here in this video, but know that you do need to check your solutions. Okay, here's another one that you can try for yourself. Negative 18x plus x squared equals negative 32. Just remember, when you're looking for a, b, and c, we need to get them all to the same side. So we say we have x squared minus 18x and then plus 32 is equal to 0, which means that my a is 1, my b is negative 18, and my c is 32. So we can actually go ahead and plug that in, but we have to get it like that first. All right, same with this one. Make sure it's in our standard form of ax squared plus bx plus c, and check your solutions. Okay, now we may not always get nice whole numbers. That's okay. We're probably going to end up with some radicals in this, and that's just fine. All right, and so we can say a in this case is 5, b is negative 3, and c is negative 1. So we go ahead and plug it in. X equals negative b. Okay, if I have a negative negative 3, I get a positive 3, plus or minus the square root of b squared, so that's 9, minus 4 times 5 times a negative 1, all over 2 times 5. All right, so I get x is equal to 3 plus or minus the square root of 9 plus, because we have a negative and a negative, 9 plus 20 is 29 over 10. Now, none of that can simplify, honestly. That radical of 29 is not going to help us, and we can't simplify it, so we just have to say my two solutions are this: 3 plus the square root of 29 divided by 10, and 3 minus the square root of 29 divided by 10. You can plug them into a calculator to estimate them to the nearest thousandth, and plug them into your quadratic. Now you can also plug them into the quadratic as it is right now, but it's definitely a little bit more complicated. All right, another one for you here, and then and I'll let you try this one on your own. It's just the same procedure like we've been doing, and then I'll show one more word problem here and we'll be finished. So from an initial height of 70 meters in a stadium, Luis tosses a ball up at an initial velocity of 5 meters per second. Use the equation negative 4.9 t squared plus vt plus s is equal to 0 to find the time when the ball hits the ground. So we want the solutions. 0 is that height, which is our y, which means we want the solutions. Now we can plug in some of these numbers and say we actually have negative 4.9 t squared. Our velocity is 5, and our height is 70, which means we can plug these into our quadratic equation and say x equals negative b, okay, so negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a times c, all over 2 times a. Okay, there's going to be some kind of nasty decimals here. That's okay. It happens in real life. This is real life. So make sure that you either do this by hand correctly or you grab a calculator and do it. But to simplify, we have negative 5 plus or minus the square root. Well, we get 25 plus, since we have a negative 4 times negative 4.9, And we multiply all that out and we get 137.2 all over 2 times 4.9, which gives me a negative 9.8. We keep simplifying, especially in that radical. We're not going to be able to simplify it fully, but we get negative 5 plus or minus the square root of 100. And let's see, 62.2. Let me just make sure that's correct. Yep, and then we're dividing by this negative 9.8. This is definitely the time to plug it in your calculator and say, I have negative 5 plus the square root of 162.2 divided by negative 9.8, and then negative 5 minus the square root of 62.2 divided by 9.8. When you do that, let's see, I think I made a mistake. I think this is a decimal off here. Let's see, let's make sure. 4 times 4.9 times 70. Yep, I was a decimal off here. So we actually had the decimal here instead, which means when we add 25 to this, we get 1397. Okay, the square root of 1397. Process doesn't really change all that much with that little error. But when we do have this and find our different values, we end up with negative 3.3 about, okay, not exact because we have radicals involved, and we have 4.3. Those are our two solutions when we plug it into our calculator. Now, which one makes the most sense? Of course, we're going to talk about the time that is positive. So we would say it hits the ground at 4.3 seconds. Okay? All right, well, I hope this helps for your homework and for studying.